Hello, we're live.
Hey everyone, how's it going? It's Friday.
Happy Friday.
Happy Friday.
Yeah, we were a minute late starting this. I don't know if Marina wants to share why.
Yeah, because I was running around trying to find the right hat.
Yeah,
So yeah, welcome Uni. Thank you for coming back for day 3 of Cilium week.
yeah,
We
and
got
I'm glad it's not my turn. I'll hand it off to you guys. But I think we covered a lot of topics. We'll finish it up today with BGP service mesh and cluster mesh. Hopefully, I've seen some of the demos and they look good. So hopefully everyone else will enjoy it as well. Yeah, it's a the stage is yours, I guess. I'll mute myself and be quiet.
Awesome. Thank you so much. I dang it. I just reran a restart command of my operator, so that's going to be fun. I shouldn't have done that, but that's okay because what I was trying to do is just move the damn window out of the way. But welcome everyone. We are going to talk about some advanced networking topics in Cilium, and this section actually is a little near and dear to me because BGP is a technology I've worked with for a long time, and I continue to work with it, and I can't escape it. So here I am talking about it again. But let's also talk about why BGP, along with some of the other technologies like service mesh and how Cilium offers that up, as well as cluster mesh. Alessandro will be covering off some details around cluster mesh and why we actually want to use this technology. Now, just to give you an idea of where a lot of this is transposed into the exam, BGP and some of the external networking is about 6% of the actual Cilium Certified Associate. Service mesh is a big chunk of at 16%, and then cluster mesh is 10%. So what are we going to cover in BGP and external networking? So there's a few things to consider when it comes to the technologies that exist outside of our little Kubernetes network, right? We also have virtual machines. We have physical and bare metal devices that exist. We might even have edge devices that live in outside networks, and they're not Kubernetes native. They're not running as containers. They're running as other types of workloads. So we need a way to bridge them into our network, our Kubernetes network. Now, there's two ways to do this, right? One of the ways, and probably more commonly used, would be something like BGP. BGP, Border Gateway Protocol, is a routing protocol that's been used for decades. Like we're talking about almost 4 decades now. And I say that because the protocol is much older than I am, and has history like that spans way before I even was in diapers. So but the technology has evolved, right? Like it's accommodated for things like IPv6 and multiple other protocols like MPLS, being able to extend your networks in different ways using the protocol as well. But let's quickly recap it, and then we'll talk about how BGP works inside of Cilium. We'll do a quick demo, and we'll jump into service mesh. So there are 2 flavors of BGP. One is called iBGP, which is an internal version of BGP. And one of the reasons you might use something like this in a network or in a data center environment is if you're really just trying to exchange network information. Most of the time, you probably wouldn't want to use iBGP, and you might use something a little bit more robust, something a little bit more dynamic that probably operates better from a routing standpoint. But it's an internal routing peering neighborship protocol. On the flip side, though, eBGP, the external BGP, is much more preferred because of the way it handles routing updates. So let me explain for a second. If you look at this diagram, you've got all of these little red circles. They're routers. I consider them to be routers. Now, when you see you see that there is a line between the red circles and other red circles, and then they're contained within a bigger circle. Now, when we have this setup right here, where we have something called an iBGP peering, That's an internal BGP peering, meaning between these three devices, they're going to be in the same network and network grouping, and they're going to exchange information. Although this is not preferred as a routing protocol, it's still a valid one in which these different neighbors will exchange routing information about routes that they know about, and then may share them in turn to internal networks that we're not seeing depicted here, but you could kind of visualize them based off of some of these other depictions. Now, when you see these links between these larger these bigger circles, right? You see this one little red circle or router. It's got interfaces or links to neighbors on the inside and then links to neighbors on the outside. These links to the neighbors on the outside are what we call eBGP peers, or external BGP peers. Sorry. I use a magic mouse and sometimes that tends to happen, so I'll try to not touch my mouse. Now, in an eBGP peering situation, this is actually the preferred approach when we're dealing with large scale networks. We're talking about thousands, or actually hundreds of thousands of routes that need to be exchanged across all of these different neighbors, because this is a subset. What you're looking at is a subset of the global internet, when it could be far more massive. Now, if you're also looking at these groupings, they're all grouped into something called autonomous systems. And these autonomous systems allow us to control the flow of these updates of routes, because let's consider something for a second. If we're talking about a massive network, if a lot of things are changing inside of this network, do these other networks really need to know about this all the time? Do they need to know about the constant updates? Absolutely not. It's actually unnecessary messages that get sent over the wire, which chew up bandwidth. For what? There's no reason for that. So we minimize those updates of, let's say, route propagations or new routes or new networks that get stood up. And we minimize those propagations so that we cut back on unnecessary messages, we cut back on unnecessary BGP processing, cut back on CPU usage and memory, and ultimately cut back on our overall routing table and what it looks like. Now, BGP itself, you'll probably find it used either in service provider networks and data center environments. It's highly tunable. You can actually influence the path of a network. So for example, you see that there are two paths for this router to get to this network, right? A direct path or an indirect path through another autonomous system. Now, why would this path over here be preferred over this? There might be a situation where this could be a 10 meg link or a 100 meg link, where these are two 1 gig links. I'd take the faster, higher speed link, even though it might mean an extra hop, which would be far faster than having to go this route. Because also you have to think about the saturation here. So BGP as a protocol, as a technology, can be very tuned to optimize for the routing of your networks at large scale. Now, where does BGP come in when it comes to Cilium? So I know it's like tiny, and you could assume that, this little Kubernetes cluster running over here. But in this little tiny network, what's actually going on is I've got a number of different workloads. Sure, I'm using Nginx, but it actually is other kinds of workloads, like actual legitimate workloads. And then somewhere else in this network, or in this massive network, I've got a database that's not virtualized. So actually running on bare metal. Now, how do I ensure that that database is accessible by some of these pods that exist here? So the flip side is also important. If I have not a database, but another kind of workload here that needs to find some information or source information that is located inside of these pods, then I also need to be able to do so and find my path around that network. So this is where BGP comes in, and Cilium as a CNI has a BGP control plane. So what does that mean? It means that I can exchange pod CIDR networks that I know about with the rest of my networks here on the physical side. So in Cilium, there are a few different CRDs or CRs to be aware of when it comes to BGP. You first will enable the BGP control plane, which actually disables what we call tunnel mode, and enables native routing mode inside of Cilium. And what that simply means is that there's no usage of VXLAN. We're basically directly interfacing with networks on our host sides with the upstream networks that we have, or our upstream routers for that matter. And I'll show you a diagram of what that actually looks like in a second. But we have, sorry, let me move forward again. I don't know why I do this to myself. Okay, so we have something called the BGP peering policy. Now, if you're familiar with how BGP peering works, or neighborship peering works, we are actually defining what we call a neighbor, its router ID, and its IP, like what peer IP it is. And so once that neighborship is formed, it's then enabled to be able to exchange some of that routing information. Now, one consideration, though, is that in order for those neighborships to be formed, there has to be IP reachability between those two peers. So if you have a BGP router on the outside and it needs to communicate with a BGP speaker or router inside of your Kubernetes environment, there needs to be IP reachability. The two need to be pingable, right? And it's because BGP operates on the TCP port 179. You can actually influence the port, but it operates at a higher level. So it's expecting you to have a connection of some sort in order for that neighborship to be established. Why this actually becomes important is this enables you to establish neighborships between BGP peers that are not directly connected. So let's go back one diagram here. This BGP peer could potentially neighbor directly with this peer, even though it's indirectly connected. This is important if you want to bypass this unnecessary neighbor and not use it as a transit, but kind of use it as a transit in some sense, in that your peering and your neighborship exchange information happens directly with these two. But as long as you have IP reachability through this router here, which you probably would through this network, then these two could form peers and be peers of each other and exchange networks with each other. Now, all right, there's a few other CRs to be aware of. There's a Cilium BGP peering policy, which basically says nodes in your cluster will peer with an upstream router. Nodes in your cluster will peer with an upstream router. Nodes in your cluster are the neighbors for that upstream router. That's important because each one of those nodes has its own unique pod CIDR. And those pod CIDRs, they actually get relayed back into BGP, right? They get relayed back into BGP to that upstream device, to that upstream router. And I'll show you what that looks like. There's also something called the Cilium BGP virtual router, which gets instantiated on every single node in your cluster. Now, there are some rules for the way you actually want to use your virtual routers. Maybe you want to have a few nodes in your cluster participate in the routing altogether. And give me a second here. I'm just going to turn on Do Not Disturb because I'm going to get pinged unnecessarily.
You're probably getting invited to like a different stream or something.
Different stream. Okay. Yeah. Okay. So there's something also very cool about the Cilium BGP virtual router. It's actually a virtual routing process that exists inside of the Cilium agent. You don't see it show up as a pod, but it's a routing process that is backed by Go BGP, which is a Go package. You can go check it out. It's widely used in a lot of other routing engines. You can actually influence how many of these virtual routers gets instantiated. Now, obviously, you will tune it according to your network needs, but if you leave it as default, it acts in a high availability state in the sense that if one of your nodes goes down, well, Kubernetes comes in, basically brings that pod back online or reschedules it, provided that it's got enough resources, and then the routing will be adjusted accordingly because the pod now showing up in the new network, its network is already being shared with the BGP networks upstream or your BGP routers upstream. There's also something called the Cilium Load Balancer IP pool. Now, the reason why this exists, and this is a pretty recent feature as well, is in Kubernetes, you have this service of type load balancer. And sometimes you will probably request a load balancer IP to expose a service, or let's say an ingress gateway or some gateway of some sort. But in the case or the most traditional sense, you're trying to expose a service to the rest of your network. Now, what's really cool with the Cilium load balancer IP pool is you define a pool of IPs that is IP reachable, or in a network that is reachable, which is associated with your Kubernetes network. And from that pool, as long as it's defined, anytime you spin up a service that's requesting the load balancer type, will pull an IP from that pool. Now, what's also cool is that same IP pool is exported or advertised as a network into the rest of your physical network. There's one more thing that's called out, is the BGP peer, Cilium BGP peer, and that's just a sub attribute that you would configure inside of your Cilium BGP peering policy. Let's take a look at a diagram for a second here. Now, inside of this diagram, I actually have 3 Kubernetes nodes, okay? And each one of these nodes has a Cilium pod, right? That Cilium pod has an agent, and that agent, once you enable the Cilium control plane, or the Cilium BGP control plane, that agent is running the BGP process now. Now, you have a pod sider because you have an app or a pod that lives on this node, right? And you've got 2 other apps as well. Now, these pod siders, right, it could be 10.x.y.z and 10.a.b.c and 10.r.s.t, whatever it is. These pod siders get advertised up to this little router here. This is a physical network now. We are at the physical demarcation point, or it could be virtual, right? Doesn't matter. But this is let's just assume this is the physical demarcation point in which it interacts with this network. It now knows and learns about these routes through BGP, through the BGP process, and then shares this with other networks out there. Now, here's the interesting thing. Even though I will learn about these networks on this router and maybe possibly relay this, in actuality, I don't re-inject these networks back into the Cilium BGP process here, because what actually happens is you actually follow the Kubernetes networking model for your pods to exit the network, right? What we're actually doing with the Cilium BGP is telling outside networks where our pods live and what specific pod resources live in which network. Now, there's a few other things to consider. You have access to things like eBGP multi-hop, like I talked about. There's the concept of graceful restart. So your data plane still stays functional and you can still move packets around, even though you might be doing an upgrade on a Cilium control plane or something, like you're doing an upgrade on your top of rack router. I talked about the load balancer IP pool, so we don't need to talk about that again. But just know that it's there, and it actually creates a flexible model as well. Also, one thing to note is that once you enable the Cilium BGP control plane, right, the Cilium agent is actually looking for a Cilium BGP policy. So it's watching for that new CRD come in. If there is a new CR that comes in, that's when it instantiates the Cilium BGP virtual router. Okay, so let's look at a Cilium BGP peering policy for a second. So if you're a network engineer, some of this is going to make some real sense to y'all. So standard, Cilium CR, we know that it's a Cilium BGP peering policy. We've given it a name called demo. It could be anything, doesn't matter. And notice here the node selector, right? Kubernetes.io/os:/Linux. I can add more labels to my nodes if I wanted to. And if I did that, then I have a flexible approach to say only 2 of my nodes in my cluster could be 5 wide, but 2 of these nodes might be dedicated for BGP peering. Why would I want to do that? What's the reason for doing something like that? So we're going to take a quick step back into 5 years ago when we were dealing with virtual and SDN and all of that stuff. You would actually allocate 2 physical nodes to be dedicated for edge services, edge networking, meaning all they'd be responsible for is onboarding and offboarding packets into the virtual network and off into a physical network. It's basically your bridge. It's basically that router. If we back up a bit, it's this thing right here, right? And all it's really caring about is high-speed routing. Now, in your network, in your Kubernetes cluster, you could have 2 of those nodes. You ideally want to make sure all of these nodes look the same, but let's just say 2 of those nodes had dual 100 gig NICs on them. So now those two nodes give you a total bandwidth of about 400 gigabits per second, right? 400 gigabits per second into and out of that Kubernetes cluster. Who knows what the heck you are doing? Doesn't matter, but that's part of the reason why you would use a node selector in that sense and label those nodes as edge nodes. Now, having said that, right, there's some other attributes to consider here. There's the export pod CIDR, which just says any sort of pod CIDRs inside of this cluster or on that node itself, we're going to advertise into the BGP process. And to whom we're advertising to is our peer, which in this case is 172.22.0.5. Now notice I am doing an eBGP peering here because my local autonomous system number is 65.100 and my peer autonomous system number is 65,000. One more thing I'll point out is that I also want to advertise my load balancer services or any sort of services with an IP. So this also could be cluster IP. This is not specific to load balancer. This could be cluster IP, it could be node port, not that you would want to do node port, but it could also be load balancer. And we're going to match on a label. So this is cool because, again, we're abstracting, we're offering flexibility. If you swap out load balancers, if you swap out your BGP process down the line, nothing here should get impacted. So are there any questions coming into the chat or nothing at all? Okay.
I might have a question.
Sure.
I'm not from, actually Uni has as well, but let me ask first.
Sure.
I'm not coming from a networking background at all. So give me a practical example. What does this do?
So you probably are familiar with creating static routes on Linux environments.
Let's say I'm not.
Okay. Yeah. So you've got a computer and your computer has a default gateway. And your default gateway will tell you about the rest of the networks and how to get to them. But you only need to care about that. Now, what you don't know is that default gateway has awareness to so many networks. It has awareness to so many networks because of BGP, for example. BGP is telling it about all these networks. How do you get to google.com? How do you get to... I'm talking about very abstract networks here, but if you were being very specific, then in your private network, it would be, how do I get to the marketing network? How do I get to my database network? How do I get to the network that has all of my videos and photos or something like that? And this is traditional stuff, right? And BGP is a process that tells other BGP speakers how to get to these networks. Here's how you get there. Here are the exit points. Here's the interface or the IP you would have to use
to knock on the front door, pretty much.
So let's take the three of us as an example. Now, I know you. I know Alessandro. Alessandro knows 1 billion people in Europe. You know 1 billion people in North America, and I know so many people in Canada, right? But you don't know who I know in Canada. But you might wanting to know about someone that works in the bank in Canada, some bank in Canada. And I can tell you about that because I know about that, right? But because we're speaking a common language.
So in this case, you're the BGP
speaker. I'm the BGP speaker. You're a BGP speaker and Alessandro is a BGP speaker because he may want to ask me about that too. Maybe I might be offline and you might have that information cached. So he might ask you, hey, who do you know in Canada that works for TD Bank? Right. And
that's the simplified version of what it does. And basically with the exporting, right, and advertising the networks and then the service selectors, you're basically saying, I'm also telling Alessandro, but I'm also telling Alessandro's friend the same thing, and that fifth person or whatever it is. Okay.
Yeah.
All right. Now, Uni's question, so I don't think of all the time. BGP. So Uni's asking, is the BGP feature applicable only in on-prem environments?
No, it's you could use it in cloud environments too, although there isn't a necessity to do so. There's a lot more available discovery in the cloud. Like it's easier to discover things in the cloud than it is like locally on premises, and you have to tune a lot of that on premises. Now, this is where BGP becomes much more powerful in that sense when you're working in large enterprise networks that you own that are private. Because in the public space, like, look, you're going to be using load balancer IPs to be able to access your services. Chances are you're not going to need to route them anywhere, right? On the flip side, if you are only talking about internally exposed services, this is where BGP comes into the mix and will help with that and help with reachability.
So, sorry, one more question from me before we continue.
Sure.
If what is an equivalent of BGP? Let's say for whatever reason I can't and or don't want to use BGP.
Yeah, if you don't want to use BGP, you could get away with using just static routes.
Okay. Basically, directly configuring a route to that bank in Canada or whatever you mentioned.
Yeah, and quite honestly, if you're talking about a few nodes, a few apps in your network, you're not going to be using BGP at scale. There's no need to.
Mm-hmm.
We're talking about large enterprise or even telco or service provider networks that run things like virtual network functions that need to know about how to get to each other. And something like that is where BGP becomes applicable, because what you would find in a telco network is something that accepts connections from, like, let's say my cell phone, right, and translates that into an IP network. And then by the way, there's a question from GK. I should move on, but anyways, the simplistic idea is that telco networks and large enterprise networks would take advantage of BGP, and the internet runs on BGP today. GK says, when should we use VXLAN versus BGP? Okay, so let me cover the external workloads first, and then we'll come back to that question, because I think it's important to talk about that as well. All right, so there's external networking that's also available through Cilium, and it's offered through this usage of VXLAN and some capabilities through something called cluster mesh, which Alessandro will cover. But the basic idea is this: I have a virtual machine, or I have a database, or I have a bare metal system that doesn't have the routing BGP intelligence, right? And this is where GK's question comes into importance here, and we could highlight that again. I don't have that routing intelligence capability, so give me another way. Let me use a tunneling mechanism, which is where VXLAN comes in. So I don't think this is well documented, and I think it just needs to be expanded upon in the documentation altogether. But the idea is you would use something like BGP to be able to reach remote networks and expose your local networks to remote networks. You use something like VXLAN as a tunneling mechanism when you need to extend your LAN, right? You need to extend your LAN and make something think it's on the same LAN or local area network as another artifact or resource. Why this was important? A long time ago, this shouldn't even be important anymore. A long time ago, in disaster recovery situations, if you changed your IP, how many things would break? Especially if you didn't figure out DNS properly, especially if you had systems that had hard-coded IPs it would make calls out to. That would be very problematic because systems weren't using DNS. Through DNS, you could use multiple IPs on the back end, and that's fine. But for systems that couldn't even process DNS and could only handle IP information, well, what do you do when you have to disaster recover to a resource that no longer exists in its original location? If it no longer has the same IP, what do? Do you go back in, change the application, change the IP when you can't because it's hard-coded? Or do you now make a bridge so that that original resource you're trying to get to now has retained the same IP? This is something VXLAN was attempting to accomplish, along with some other areas. Now, the use case I'm describing right now, where your external workloads exist, might be that database where it cannot be containerized. And we don't have routing intelligence, like we can't use BGP. So this is where something like VXLAN becomes important. So cluster mesh behind the scenes will use VXLAN and technologies like it to be able to establish a laneway or a road or a private laneway directly to some external resource. What that means is that external resource now can talk to pod resources, vice versa. And this is very much what we're doing with external networking for the external workload section here. Now, that being said, even though you can extend your pod network to a physical network or to a physical resource, no encryption currently works. So even though you have basically just extended a wire, which is virtual, there is no IPsec or no WireGuard. Now, the other part to it is, when should you use VXLAN versus BGP? BGP is, again, for larger scale networking. If you have many, many networks that you're trying to learn about, and also limit limit how much you learn about, because it can also chew up your routing table, take up memory, and also become much more challenging to reconverge. Like if you actually have to do a routing update, because now there's a much more optimal path, it may take your application much longer to realize that there is a better path available, right? Anyways, there's a lot of considerations around that. GK, if you want to have a deeper discussion, reach out, send us a DM, or even ask a deeper question about it. If there's something that you're trying to achieve, I might be able to give you some perspective there. Okay, one more section on external networking, and then we'll move into demo. In a dynamic environment like KS, I'm assuming Kubernetes, where pods come and go, does the new route propagation happen instantly? Well, okay, so let's think about this for a second. My pod CIDR is always going to stay the same. My pod IPs might come and go, but they'll still be in the same CIDR. So what that means is that CIDR is still going to be advertised to the rest of the network. Now, if something on the outside is trying to reach that pod or that IP, one, obviously that's a bad approach, because you don't want to directly communicate with the IP. You want to communicate with the DNS name. But two, if it's unavailable, then you'll just get a timeout or something like that. Okay. So there won't be a route propagation for any time a pod comes and goes. If there's a new node that comes online and is added into the cluster and is added into the BGP process, its pod CIDR will get propagated into the rest of the network. Okay, so there's just a few steps on how to get external networking up and running. You can install Cilium with the tunnel equals VXLAN in the flag. You enable cluster mesh with load balancer services enabled. Oops. And you also want to create a Cilium external workload object that tells Cilium about this external workload. So you're basically telling Cilium, hey, this external workload exists here, and this is its IP, this is its name, and treat it as an artifact inside of Kubernetes. Then you can proceed to go into the actual bare metal or virtual machine, install Cilium, which is just the bits for Cilium and its cluster mesh capability. And once that's up and running, you can test connectivity, and you should be able to reach pods. Pods should be able to reach this resource bidirectionally. And that should give you an idea of how it works. Now, there's also another type of integration, which I forgot that I had created a slide on. And this is another on-ramp mechanism. So let's just say you have a physical network that you want to on-ramp into your pod network. Well, you could use something called the VTEP integration, which is the VXLAN tunnel endpoint integration. This has been done for years through tools like NSX. Arista has been doing it. I mean, a lot of vendors have been providing this capability. A lot of you might wonder what the heck and why VXLAN. So VXLAN is actually a MAC and UDP tunneling mechanism, but its other main reason it exists is because if you're familiar with VLANs, there's actually a limit on how many VLANs you can have per system, and that limit is 4,094, 96 VLANs, and usually you'll shave a few off for things like management and experiments. Now, if you're that limited and you're honestly creating many, many more networks than that, something like VXLAN is probably more ideal, because it offers up the same broadcast domain functionality as a VLAN does, except now you can span multiple nodes and you can span IP, meaning you can carry your layer 2 broadcast domain across a larger IP boundary. Let me be very clear about this. If I have a node that exists in Toronto and I have another node that exists in, I don't know, Seattle, Redmond, somewhere near Peter, and I have another node that exists in Amsterdam, and they were all running VXLAN and they were all tunneled to each other, basically anything that lived on top of it, any sort of applications that lived on top of it, would be treated as if it was in the same IP network. So that's what's going on here. All right. Oh gosh, I have another slide I completely forgot about. Okay, egress networking. So you can do egress networking as well, and it's very similar to this concept of source NAT or port address translation overload. So if you had a public IP, for example, that you were trying to NAT masquerade to multiple private IPs, well, this is exactly what egress networking is doing. You could also use an egress networking policy, which I'll show you over here, and that can control the CIDRs that you can communicate with outbound. So it's a mechanism to control the flow of traffic from your pods to outside networks as well. Okay, let's do a quick demo of BGP. And if you want to quickly scan the QR code, you can also take a look at that repo, which would give you an excellent idea of how BGP works and how to set it up in your own little environment. And I'm going to take a swig of water while we take a look at any sort of QA that might have come in. Peter, any QA?
Nothing that I can see, no? So
Awesome. Okay, cool.
Well,
Oh, nothing. I noticed
Well,
I was muted, but no, I didn't have a question.
Awesome. Okay,
yeah.
so let me share my screen again. I will share my window. Hold on a second. I have to be sneaky here. Dang it. Let's see if that tab is there. That's okay, whatever. Okay, so I'm in a virtual machine that's running Docker at the moment, and you can pretend that you don't see anything else other than my terminal at the moment. And so let me just show you what I've got going on. So I'll launch K9s. And I like K9s. K9s is cool. I literally looked at it last year and I was like, whatever. And then I saw others using it. And I'm like, what's wrong with me? So we'll just get all the pods, right? And I just want to show you that I've got Cilium running, and I've got 2 Nginx pods as well. And I want you to pay attention to the IPs 10.242.114.44 and then 10.242.2.55. So these are the 2 different pod CIDRs, 10.242 and 10.242.2, or 10.242.1 and 10.242.2. Now, what I could technically do is I could advertise a single /16, which would just mean that anything here, and as long as I have this as an identifiable subnet, would mean that any pod would be caught in that massive route, meaning I'd know about all of these different Nginx pods. But anyways, I've got that running. I've also got what we call a Cilium BGP pure policy. And it's similar to the one that I showed you earlier, right? Where I've given it a name, wherever that name is here, Cilium BGP pure FRR. And there's a bunch of configurations. Actually, you know what? It's nicer if we look at the YAML instead. So we'll go YAML, and it's a lot cleaner. Now, here's what I was referring to with respect to the entire configuration that's super relevant to the routing. So any node, we've got a few nodes that match this, will actually be advertising networks and will peer with an upstream router. Our local ASN for each one of these nodes is 65,013. We also have a few things set up here like graceful restart, so that anytime our control plane goes down, the data plane will still stay alive and the routes won't be flushed from anyone's routing table. There's a few other settings that I've set to, and I've also specified my peer ASN and its address. And there's a couple of other things, like I mentioned before. I'm exporting my pod CIDRs, and this is applicable to all nodes in my cluster. I'm also advertising any sort of services and their IPs that match the label app equals Nginx. So if I did a pods, right, is there a way to see its labels? Probably not. Okay, that's fine. Let's exit out of here. Let's go kubectl get pods -- show labels, right? And we'll notice that we've got the app equals nginx. And if we do get svc, which is the same, yeah, we can see app equals nginx. And one last thing, get nodes. I just want to show something important about the nodes. And if you notice, right, each one of these nodes, it has that Linux label. So we know that it's a Linux node, and we know that we're going to treat this as a control plane. Now, I've also got another command here, Cilium BGP peers, which tells me I have upstream neighbors, or one upstream neighbor, which has the address 172.190.1. So that device actually is this FRR device, FRR2. And for network engineers on this, right, VTYSH is just the virtual terminal of the actual router. So if I do a show IP BGP, there are my neighbors, and those are the routes that I learn about. Now remember, actually, no, those are just the routes I learn about. But if I do a show IP or show BGP neighbors, summary maybe, brief. Actually, maybe show BGP.
And these neighbors in this case would be the
nodes,
3 nodes or 2 nodes, right?
Yeah, there's another way to display the neighbors, but here's one BGP neighbor, 172.20.02, right? If we scroll up, you'll see 20.03 and then 20.04. Actually, no, you'll see 19.03, 19.04, 19.02, because there's another neighbor. There's another neighbor that's onto the other side of this, but that's fine. There's also one more thing I'm going to show you all.
And what did you? So you did Docker exec, right? So did you run this from one of the nodes in the cluster, or where did you run this command from?
So Docker is running on this Linux VM at the moment, and this is just a standard container that is sitting outside of Kubernetes at the moment.
Okay, so you're just unrelated.
Yeah.
More or less, right? It's just
it's outside, it's unrelated, but it's actually on a network that is attached to the same nodes.
So that's why you can see that. Okay, so this Espresso and BGP thing is just an image that's running, a container that's running, that's in the same network, I guess.
Exactly. Now this PC1 though is resemblant of a PC. Like this is an actual terminal, and if I do an IP route or show IP route, or maybe IP route. The thing that I want to point out is Docker networking is a little interesting. So ignore Docker networking and its weirdness. The most important thing that is critical to me is I know how to reach the node network, and I know how to reach the pod CIDR network. And this is the service CIDR network too, which I didn't show y'all.
And this is all done by the BGP, the peering policy that you've configured, right?
Yeah, and actually the previous interface that I showed you showed us the routes that it learned about from BGP from Cilium. So we learned about that through Cilium, and I'm just now going to test that I can reach those pods from an outside entity that is using that router that we just looked at to go to Cilium to talk to these pods. So if I did a curl to that pod IP, and not that pod IP, that's actually the service IP of the nginx pod, it works just fine. So what that's telling us, if we go back to the diagram, right?
Yeah. So while you're switching, so the GK is asking, the Docker container is acting as a router gateway for Kubernetes nodes. I think it's, if I try to explain it, if I understood correctly, it's just a container that's running, that happens to run on the same network.
So if we look at this diagram for a second, that test PC that I was just on running that bash command
is just down there.
Yeah, so it's on its own little network called BGP2, which is interfacing with Tor FRR2, right? And Tor FRR2 is interfacing with the Kubernetes nodes on the far right, which we are not fully seeing, but that's how BGP works.
Oh, okay.
So
But it's all separate networks, and with the peering policies and all this, you can make one thing see the IP addresses from another one through the BGP, right?
exactly.
It,
So
it's really about like It's a cool feature. So you get this flat network we can see deep into another network because the routes are advertised by the routers, right? So that's the power of BGP. It's not for everybody for sure, but
yeah, I mean, most of the time, platform teams won't really interact with BGP. You might find cloud teams and cloud network engineers, and maybe network engineers interacting with it more. But as we start to see more and more complex use cases pop up, I can see BGP re-entering the chat in a much more grander sense. So, all right, I spent a lot of time on on BGP and external networking.
there's
You're
this question from
Yeah, there's a question here. Can you ping the load balancer IP from outside the Kubernetes cluster? So load balancer, or that service IP specifically that was I curled to, that you saw just a moment ago, I can't ping that. It's an artificial IP that doesn't exist. It's actually being mapped directly as a service to those backend pods, unlike a load balancer itself. So a load balancer IP, on the other hand, right? We're actually talking about a load balancer that's presenting an IP that you would interface with, which also gets assigned to the service that you choose that you want to assign it to. So that's something I can ping, but I cannot ping this service IP specifically, even though it is a quote unquote load balancer IP, because it's being issued by Cilium through the load balancer IP IPAM pool. Okay, service mesh time. All right, so Cilium Service Mesh is something that was launched sometime around last year, and it offers a number of different capabilities. And there are a few things that you should know about how Service Mesh functions inside of Cilium. You should know how to use the ingress capability inside of the Cilium Service Mesh, how to use Gateway API. And I'm not talking about deep super experience. Oh my gosh, I'm configuring a whole bunch of different backend routes and whatnot, but know what these are and be familiar with the Kubernetes ingress and Kubernetes Gateway API. I'll cover some service mesh use cases. We'll look at Gateway API. We'll talk about some encryption and understand service mesh sidecar versus sidecarless and how mutual auth comes into play here. So service mesh use cases, there's 5 key ones to really think about with respect to this exam. Resiliency and ensuring that if there is a failure in the network somewhere, or there is latency, or there's saturation, well, we should be able to recover. Our app should be able to work around that particular condition. And that's what Service Mesh will offer. So you might see things like retries or some resiliency through some means of like being able to implement some circuit breaking or delays just to bypass failures inside of your network. There's also the need to do some layer 7 traffic management. So you have intelligence that lives in your HTTP headers, and you can make some routing decisions based off of that information. Or you could even apply policy based off of what's inside of that header. Or you could basically say, I can run certain actions, HTTP actions, against certain resources if I have this right token or right auth mechanism. And then there's identity, like knowing who is who inside of your environment. So every single workload has to be attested. And then there's the element of observability and tracing so that we can see what's going on. We can troubleshoot what's going on when. We can troubleshoot latency issues, any sort of errors in our request paths, and then understand general latency around CPU and RAM utilization, and even network bandwidth utilization. But the final piece around that use case should be transparency. So your app really shouldn't know about it or know that a service mesh is there and that they are using it. So Cilium Service Mesh offers 4 key capabilities. It offers Kubernetes ingress, Gateway API support, mutual authentication, which is a flavor of mutual TLS, and layer 7 aware traffic management. Now, Cilium ingress versus Gateway API. Now, Cilium Ingress offers the standard Kubernetes ingress capabilities. So you will specify Cilium as your ingress class, and you could specify whether or not you're going to use a dedicated load balancer or a shared load balancer model for ingress. There are situations where you might pick either or, depending on how much resources you have, or if you've got unlimited resources for that matter, and you're willing to fork over load balancers for a variety of different kinds of apps. And then there are several different annotations that are supported for the ingress capabilities for Cilium. So you could go take a look at that in the docs if you really want to know more about those, which I actually recommend everyone go take a look at the docs too, because you never know if one of those annotations might show up. And then Gateway API. So Cilium Gateway API is offering up the successor to the ingress resource. Now, Gateway API, as we already know, is going to be the successor to ingress at some point. I mean, it's there. There's still a lot of work being done to it. There are a few different resources that are available that Cilium offers, like the gateway class. So you would specify Cilium as your gateway class. It would offer up a gateway as well. So there's a gateway resource that gets spun up and that actually accepts communications inbound and will terminate, TLS if you want to. There's also the ability to do HTTP routing. So if you have multiple services that you're trying to route to, you could specify where to. And then there are a few other features as well, like the TLS experimental route and the reference grant. Now, why would you pick one or the other, right? Now, Cilium Ingress has limited support for advanced routing. So you can't do URL rewrites, you can't do header modification, and you can't do traffic splitting. You can only do HTTP or HTTPS, and there isn't a role-based model that the Ingress resource offers in Kubernetes, which is why Kubernetes Gateway API exists, because you do have support for HTTP routing, TLS termination, and traffic splitting. You can modify the header if you want to, and then route based off of that. There's support for external traffic policies, and you don't have to worry about annotations. So it's very customizable, and you don't have to deal with annotation sprawl. And then it also offers up a role-based model where you can have a team of infrastructure architects that deploy the tooling, and then you have another team that deploys the artifacts or the resources that would be consumed inside of, something like Cilium. And then you have developers that just consume the actual resources like HTTP routes and gateway resources. So, all right, encryption. Encryption's interesting because Cilium offers two particular flavors, IPsec and WireGuard. Now, IPsec's been around for a very long time, like a long time, decades, multiple decades. And the simple idea of what IPsec is I want to form a secure encrypted tunnel using, a variety of ciphers, or have the option to pick from a variety of ciphers, negotiate on those ciphers, negotiate on a common certificate that we can agree upon for pre-shared keys, and then, encrypt all of our traffic that's in motion, but also prevent things like data replays and prevent any sort of modification of that data that's in motion. So that's what IPsec offers, and it's been doing so for a long time. WireGuard does the same thing, but in a very much more lighter weight sense, and it uses different ciphers altogether, but also offers up a faster experience and faster onboarding in a different sense. IPsec does have a lot more overhead than WireGuard in some ways. Now, to enable both, it's just really a flag where you have to make sure that set encryption enabled is true, and then you also set your encryption type to either IPsec or WireGuard. Note that intranode encryption does not exist. Internode encryption does exist. Now, why is that important? So if you are inside of a node anyways, need I say more? If you've got root access to that node,
It doesn't matter.
It doesn't matter at that point, right? So there's no point in encrypting between workloads in the same node. All right. Now, mutual authentication is an interesting one because it's a little bit different in the way that it works in comparison to MTLS. So while Cilium itself doesn't directly offer MTLS, sidecars aren't present in this situation, right? We're using eBPF to optimize the flow of traffic and whatnot. Here's how it actually goes on to achieve MTLS-like capabilities. So identity allocation is the first bit. Cilium has to assign unique identities to each Kubernetes pod, ensuring clear distinction and secure communications between pods. This step is actually very crucial for defining access controls and policies in some of the following steps, because if we don't have identities for any of our pods, and we're just relying on what Kubernetes knows, and we can't establish our own little internal database, doing policies becomes a little bit difficult, right? Then there's this element of certificate generation where the Cilium agents are going to issue SPIFFE-based certificates to pods, not necessarily directly to them, but assume their identity. And then they'll be used as the mechanism to establish that identity for each one of those pods, but they're not always going to be persistent. So this is like the initial basis of, let me verify you first. So once I've done that initial verification, I can proceed to assume that through something called the auth cache, which is that little yellow box, I've basically logged the fact that I've already authenticated this identity. I know that this is a valid identity, so I don't need to continually maintain it. I'll refer back to my auth cache, and I will use something like WireGuard encryption to make sure that all my communications between services across nodes is always encrypted. So what does this mean? My Cilium agents will source my identity document for me through a SPIFFE format, and will assume the identity for my pod resource. It'll be stored in auth cache, so I don't have to keep maintaining this. And I will do this for every single workload. Once I've got my auth cache and I've verified the identity of, let's say, pod A, and I've done the same for pod B, I now can use something like WireGuard encryption to make sure that I have an encrypted data path. And that's how I achieve my mutual authentication. Now, there are some limitations in this, so I encourage everyone to go and take a look at the documentation to understand what those limitations are and what you may need to consider, because this is still currently beta. All right, so let's also take a look at sidecar versus sidecarless, and then we'll move into, this demo that I have. I think it should work, but if not, we could always pass it along to Alessandra and come back to that demo after the fact. So sidecar versus sidecarless, right? In the sidecar, we're using Envoy in the data path. Now, if you look at some other service meshes, and I'm not going to get into super details here, but a lot of service meshes use the sidecar pattern where it's deployed as a secondary container along your main application container, but it's proxying connections for that main application container instead of the container itself receiving those communications directly. So the sidecar is going to be that proxy responsible for policy, for traffic management, and feeding and observability. It'll also do things like layer 7 authorization. It'll terminate TLS. It'll allow you to implement some rate limiting or fault injection or delays so that you can implement resiliency between your microservices. Now, that's what a sidecar offers you, in addition to what you see on the right, where you get traffic management at layer 4 and 3. And you also can do things like canaries. You could understand your topology a little bit better and set up things like multi-cluster and still be able to communicate with services across different clusters. You could set up a network policy boundary that spans multiple clusters and enable MTLS-like functionality through mutual auth. And then you still have observability through layer 3 and 4 and through flow information, while OTEL is still present, or your tracing information is still present. Now, why you see this distinction here is that in certain situations, that sidecar model becomes very important, especially as you're trying to build additional resiliency into the way your applications behave and respond and, just work. Whereas in the sidecarless model, you're going for a lighter weight approach where you're still getting a good chunk of the benefits of what a sidecar would give you, but without the additional overhead. So that being said, here's a model in which it could look like, right? And we'll dig into a quick demo. Hopefully it works. Crossing fingers, because I was just messing with this right until we were here. And if not, that's cool, because I'll explain a little bit about what's going on. And Peter can also jump in because he's a Spire expert. So while I'm doing that, please do ask your questions while I'm pulling up this other environment.
Yeah, so there are a couple of questions. Well, Sanjit is saying hi, guys, so hi back. But Egbert is saying that I have a BIOS router with BGP setup and K3S cluster. Would Metal be talking to? I would leave this to you, Marino, to answer, because there's like a lot of words that I don't
Yeah. Okay. So let's break this down. VIOS router is just another virtual router like FRR, which is sitting externally. K3s and MetalLB. So MetalLB isn't required for using BGP anymore. Just letting you know, Egbert. So you could drop MetalLB if you're trying to use it with BGP inside of Cilium. If you're using MetalLB to expose other services, understandable, not required for Cilium because you can use the load balancer IP IPAM pool. Now, you're correct. You can not, well, I don't know about the load balancer IP, and I don't know why you can't ping it, because I know MetalLB has two methods of being able to advertise networks through the layer 2 advertisement and as well as through the BGP advertisement. But if you're not using MetalLB, then Cilium will take care of this for you through its BGP control plane and establishing peering policies. So your BGP peers would be your nodes in K3s, your K3S nodes with your VIOS router. That would be the BGP peer there. Other questions? Oh yeah, so Egbert did say, I think Cilium works the same. Definitely will try Cilium out. Cilium used to use MetalLB before the BGP control plane was fully established. There's a question from Addis. Peter, I have problems setting up Istio MTLS. I will let you take that one, Peter. If
Yeah, I would say there's not enough information to figure out what's happening. If you have like a specific error that you're getting, saying it's not working, it's not giving me a lot of information to figure it out. So yeah, you can join, ask on Slack, ping me on Slack, ping me on Twitter, with like, ideally, and for anyone else, like I love to help people with different things, different issues. If you really want me to like make it easier for me to help you, have a minimal reproducible YAML or anything that I can just apply to a cluster and try to run it, that would, like, you'll get an answer much faster and quicker for me. All right, back to you, Marino.
Awesome. Yeah. Okay, so as part of Cilium Service Mesh, there's a couple of things that I wanted to attempt to do, and I think there were some, I don't know, could be just my setup and it being a little bit buggy, but I think I found the right setup where I wanted to demonstrate gateway API as well as mutual authentication, but I think I can only do one or the other, not both at the same time. So I'm probably going to open up a PR about that and try and learn a little bit more. Or there's probably an issue about it already. I don't know. I haven't spent the time to look. But I wanted to point out that the way I installed Cilium, right? And I'll show you this. Control. So if you look at this, right? Helm install Cilium version 1.14.5 namespace kube system. I have this set to true because I wanted to use the gateway API as well. So that's not necessarily needed for the case of turning on mutual auth. But what is actually needed for mutual auth is if you see the set authentication.mutual.spire enabled true, and then you set authentication mutual Spire install enabled true, this installs Spire as well as the Spire agents and the Spire server so that you could start doing mutual auth, and it proceeds to go and attest the workloads as well. So technically, Peter, I mean, if this looks good, right? If my Cilium status looks good, it should work, right? I mean,
yeah, I think it should.
So let's take a look here, and I'm not, and all I want to see is that the Cilium agents picked up on the fact that these are tested workloads. So
Yes.
I think you kubectl exec, was it an exec command? Yes.
Yeah. So we can look from the server because server does the registration of all workloads. So there should be something in here. Yeah, so it's not, but we can look at the Spire agent as well if you want to check that out. Or I would even look at the logs from the Spire agent to see if that worked.
Okay, so let's try that. So kubectl get pods dash and Cilium Spire.
Yeah, and then I would just look at yeah look at the logs and we'll see if there's anything. Like this is still in beta, right? So look at so you will have to look at the specific pod that runs on the same node as your workload.
Oh yeah, that's right.
Right?
That's right.
Because so the Spire agent runs as a daemon set, and each one per node, and then Spire agent on that node is responsible for issuing
so worker
issuing SVIDs to the workloads running on the same node. So
yeah, so it'd be that one. The one that ends in NMH.
XW, yeah.
No identity issued.
Yeah, so there's something.
I'm wondering if I need to bounce the Spire agents. Actually,
yeah, just do that. Yeah, try doing that. Yeah, or just, I mean, the server as well. But there were errors in the operator before, right? Oh, it said demons.
DS or
RS probably. I'm not sure. What?
Oh,
it's Cilium Spire.
That's my bad. Get DS, Spire agent, get deploy. Let's just see. Oh, there is no deploy.
Oh, because it's daemon set, right? You're not gonna get the deployments. It's one per node, right?
Can I can roll out restart, right?
Oh, I can try. I don't know if it works on the daemon set though, but
it did.
It did? Well, there you go. Perfect. And I would look at the logs again. I don't know. Yeah, the ID is going to be different. So
I could do this. DS.
Well, but this one is not going to show you, right? It's just picked one.
Yeah, that's true.
Randomly. Yeah, I don't know if there's a command that would, like, I would love to see logs from everything, you know, if from the daemon set. There might be something in the CLI, but I'm not sure.
Okay, so this is the new one. All right.
Yeah, it's the worker too. And let's see if it doesn't work. Exercise to the viewer to try and make it work, I guess.
Yeah, and I'll pass it to Alessandro to
to do the
Oh, why didn't it find anything? Defaulted container out of spot. Oh, I did the logs. That's why.
Yeah, that was fine.
Yeah.
You wanted to look at the logs. Yeah, I don't really know why. I mean, we can look at the operator logs to see if there's anything.
Nah, that's
why is operator a deployment or is operator a daemon set?
This one?
Yeah.
This is the deployment.
Okay, so so there's a deployment with 2 instances running. The reason I'm asking is because you have 3 nodes, right? And if it's a daemon set, the Cilium operator, if a Cilium operator is a daemon set, why do you only have 2?
It's not a daemon set. This is
the
deployment. Yeah.
What happened there?
Nothing.
No. I got like balloons going through my screen.
Oh, maybe
my video.
So maybe what I'll do is I'll try and troubleshoot this while I pass it to Alessandro to dig into the other stuff. So go for it, Alessandro. Let's dig into the cluster mesh action.
Oh, there you go.
Of course, like computer just crashed, so I switched to the laptop, and everything should be set up. Let's see how it goes. Let's see. You want me to share my screen and the
Yeah.
end the presentation. This one. All right. Let's drive this. Why not? Let's share the entire screen because that's what we do. So we were about to talk about cluster mesh, right? So first of all, I'm amazed because I mean we got our own very own BGP expert in house. So every time I need to know anything about BGP, I go to Marino because that's he is the expert. He presented it in Detroit and sorry, in Chicago about BGP. I was looking at your video, so all good. So BGP is one thing, and it's clearly as a very specific use cases. Now we're talking about cluster mesh, which I think is there for longer in Cilium. And the main goal of cluster mesh is really multi-cluster connectivity. So connecting multiple clusters so those clusters can expose services globally, right? So you can have a service that can be present in multiple clusters. You can load balance over those services globally across all your estate of cluster. It's a very specific use case. It's I think it's a pretty mature feature. At least I found no problems in setting up the demo. Services code works out of the box. Just an annotation services. So I think it's safe to say that this is. I don't know. I don't know much about like the release status, how features are promoted within the Cilium project, but I would say this is something you can use right now. So, and it's part of the exam, so you better know how to set up a cluster mesh. I have a small gist that I will share soon in the chat. So how does it work? It works by exposing API servers from multiple clusters to each other, and so they can read from other clusters the service definitions and can make those services available to every cluster, right? So use this extension Kiwi Store Mesh to cache remote cluster information. In my demo, I don't deploy with that, so we'll just use the classic mode where the API server have to talk to each other. Is one important thing I notice, of course, in the when I set it up. So you need to have a shared certificate authority for this to work properly. So you better have like a one certificate authority that you distribute in some out of band way to multiple API servers of Cilium, so you can you have one, so the servers are trusted, and it works by exposing the API servers to each other. So you must have multiple clusters, but they must have some kind of visibility to each other, right? So you need to have the clusters that can expose the API server, the Cilium API server, through some mechanism. Most likely is load balancer, maybe it's node port. In our kind clusters, we use node port, but you better have the clusters either in the same VPC, Azure VNet, or whatever, where at least they can communicate. So there's no firewall in between. There's free communication between the clusters. So that's one limitation, but you can probably be creative and find a way. Maybe BGP. I mean, that's when I was listening to the BGP story, maybe I was thinking, can cluster advertise each other and see each other? Maybe there's some exploration to do there. And one very important prerequisite is to have non-overlapping pod CIDRs across clusters. So why it's important? Because, of course, those endpoints, they have to be unique per cluster, right? So you can't have two clusters assigning the same IP to pods that belong to the same service. So the easiest and more the surefire way to ensure this is that every cluster, although the pod CIDRs are kind of like made up IP addresses, most of the time it depends on the CNI they use. but you have to be careful when you set up these clusters; they don't overlap. So you assign these virtual CIDRs for pods in different ranges for different clusters. So this is something that gotta be careful with. So something that we achieve by, and I think you can see my screen. So this is a GIST. I think this is a GIST. So I think I can just GIST github.com. You can find it on my one, but I can share it with the group maybe in a bit. I always have a problem with this chat, so maybe somebody else can share it. So the whole point of creating this cluster with kind is that we can select the pod subnet, and they are clearly different. They exist in two different ranges of the spectrum, and so this is what I did already. So I don't bother you with the cluster creation. So I have two clusters, of course. So you can see from Docker that I have two clusters with two nodes each. kubectl minus context. I can first let me export this. So kubectl minus context cluster 1 cluster info. So you see there are two different kind clusters, and they don't have any CNI right now. So of course all pods are in most pods are in pending states, the ones that are not part of host network, of course, but we don't have CNIs yet. So first of all, we install Cilium, that's clearly what you need to do first, because you need Cilium. And notice this flags that I'm using. So I'm saying give an identity to the cluster. So in Cilium, with the Cilium install, we talk about it the first day. So you can pass all sort of Helm chart values flags to the Cilium install. And in this case, I'm passing the flag cluster name, cluster ID, and also I'm setting the IPA mode to Kubernetes. So I'm delegating to Kubernetes the assignment of the IP addresses, because our kind cluster already have pod CIDRs, and so we should be good to go. Just get Cilium status. I think everybody can read, right? So no one, because I can't read the chat, but I suppose everybody's happy. I'm doing minus wait, because of course this is not ready yet. Cilium is getting is getting the pods up and running, of course. Cluster 1. So you see there are pods being created. Of course, now that I have a Cilium agent running on the node, finally core DNS is up and running. And so if I do this now, finally, so this is a working deployment of Cilium. And this is one thing that, because now we want to install Cilium on the second cluster, what we want to do is also to copy over the Cilium CA. So Cilium CA is generated part of the process of installation of Cilium. So I'm just gonna get it from the first cluster and reapply it, apply to the second cluster. See, it's a nice little trick that we're using here. And finally, we are installing the second cluster, right? So we get in same thing, cluster name, cluster 2. The cluster names have to be unique, and also the cluster IDs need to be unique. So let's see how's this second cluster doing. And soon enough, we're gonna get so the minus wait actually waits for the pods to be up. So it's a safe way not to go too fast, right? So not just enabling cluster mesh when you don't actually have Cilium available. So this reported now after a few seconds, of course. that is okay. So the cluster mesh is disabled because it comes disabled when you do Cilium install. And with these two commands, I'm just enabling cluster mesh on each cluster. So these are just enabling cluster mesh, right? So they are not connected to each other yet. We're just enabling the components of cluster mesh into each cluster. So this should also be pretty easy. There is an auto discovery of the service type that is most correct. Although in my case, we didn't make it work. It wasn't working, so I have to specify that I want service type node port to be the way the Cilium APIs are exposed to the outside world, to each other, really. And so
will this command deploy something on the cluster, or
Yeah,
what does it
it
actually do?
It does. What exactly? Yes. So you see the cluster mesh API server is now running. There was, of course, like a job that generated pairs and stuff, but there's actually a new API server. I might actually, I didn't.
Oh, and there's a service, I'm assuming, as well, right? And
there is a service. Yes.
That's where it's like an east-west gateway
and the
type
service
of
is
thing.
type
Right?
node port, of course.
Okay.
Right. So yeah. So this will be in a cloud environment, of course, like probably a load balancer type of service. Depends on your architecture. Maybe you have like clusters in the same VPC over different subnets. It's really depends. So with node port is just the easiest because. But of course, with node port, if you change if node scale, then you have to somehow refresh the list of IPs. I read this in the doc, but and finally, you connect the clusters to each other. So this is an interesting command. So you give you execute on cluster 1, and you give a destination context cluster 2, and this will make the magic of connecting over the node port service, connecting cluster 1 to cluster 2 and cluster 2 to cluster 1, right? So that's
so it doesn't really matter which one's first, right?
No,
it does the both way. Yeah.
It doesn't matter. I didn't try with with more than 2 clusters. If you have to do it once per cluster, or have to make some magic. But I guess for every cluster, you can just connect them to the first one, and then they
Then
they get the configuration, right? So I should go to this repo yes. So normally that's why I try to be a bit different, of course. So the classic demo application is the Star Wars. In the Cilium world, like everybody demo this Star Wars. I'm not a fan of Star Wars. I'm more of a Star Trek kind of guy. If you know what I mean, of course, I prefer.
There's something that doesn't have to do anything with either of those two things. I was talking to Marina about the similar topic yesterday. It's like, I don't get the references. I'm not a star. Maybe this will make enemies now. I'll make enemies, but I'm definitely not a Star Wars. Star Wars is the one with the green guy, right?
Yeah, Baby Yoda. Yeah, but so it's two philosophy, right? So the world of Star Wars is this bad war where there's an empire and
I know, but see, I don't like when that's used in a demo. I don't get the references because I don't know what a Death Star is and what is a fighter, and I'm like, I don't know, is this good or bad but anyway.
Okay, so
I do like Star Trek, but the movies.
Star Trek. Maybe we should have a demo app with the Voyager.
Don't do demo apps with any. There was another one that I brought up. It was the Pokemon thing. I think GraphQL had that, and I'm like, I don't get this either. Like, I'm not a Pokemon. Anyway, sorry.
My son is crazy about Pokemon, so maybe I'll use that. But no, this one is straight from the Istio world. Actually, it's the Hello World, right? So, and why I use this because also the Hello World can return the some environment variable like the name. So actually I created this slightly two different. I can actually diff Hello World cluster 1 and Hello World cluster 2. So they are labels, right? Labels are attached to this to these two different deployments, so I can distinguish which deployment is where, right? So I can say, and this will come clear when I call this service, this load balance across two different clusters service. So they you will see they will return different times from different servers, different clusters. I'll just scale them up because I like to have like more. So it doesn't matter how you scale, but so what matters is that you have a service, of course, of type the Hello World service, right? So this is this part of the deployment. And crucially now, we annotate those services in both clusters to have service Cilium IO/global equal true. This will just signal to the Cilium API server, the cluster mesh API server, that now these services have to be shared among all the clusters. Importantly, they have to be same namespace, same name of the service. You can't just pick and choose different names on different clusters. No, it have to be in exactly the same namespace name and exactly the same name of the service. And if they have the annotation, bam, now they are global global services. So how do we demonstrate that that this is true? We run like a, usually in Istio, this is the sleep pod. I have the Nest shoot because that's what I do most of the time. So now I have this services. I'm on cluster 1, right? So this is actually on cluster 2. And if I curl the service in the local cluster, because this pod, the Nest shoot, runs in cluster 2, and now I'm just curling hello world in cluster 2, you see that I get almost 50% of the request coming from cluster 2 and cluster 1, right? So now I'm actually load balancing across two different clusters from the same service. So this is the basic demo about cluster mesh. So with a very simple setup, I really had to just deploy Cilium on both, expose that, enable cluster mesh, kind of expose in some way the cluster mesh API server to each other and connect them. And that's it. That's all you need to do to have globally visible services, right? So this kind of it's the demo. So it's nothing crazy about it, but imagine the possibilities, right? So you can define services that can be visible over multiple clusters. So this you can also set service affinity. It's another annotation where, of course, like if there is an endpoint to the service local to that cluster, keep using it. If you set service affinity to local, then prefers to route the request to the local endpoints. You can set service affinity to remote, and that will prefer remote endpoints. Or I think or you don't define it, and then you get just a load balance across all clusters that expose that service. And of course, you can also now have Cilium network policies applied to cross cluster, right? So that's very powerful as well. So now you get this extra label that you can use to target services, use it to target the Cilium network policy 2. And so you get this Cilium policy cluster 1, cluster 2. So you can also do more sophisticated Cilium network. So certain network policies are now aware of the topology of the clusters you have, and can be applied to different in different ways. So that's about it. So what can we do now? You were checking something on for your demo, Marino?
Yeah, so I still have to troubleshoot. I don't know why it's not working, and I tried it in another environment as well, and I was getting the same results. So there could be an issue open with the Cilium open source, and I might have to just go research that a little bit more and see if there is a workaround. But there will be a session coming up. I think, Peter, you shared it, where you're going to dig into Cilium mutual auth very soon.
Yes. That's going to be on Tuesday. So next Tuesday, we're doing a live stream with Christian Posta. We'll look into how Cilium mutual auth works and some of the pitfalls there.
Sure. So there's a question from Egbert: how to set up cluster communication on different interface than India? I'm not sure I understand the question, but maybe.
Well, if I get the question correctly, so cluster mesh doesn't have an opinion on how you expose them, but they have to be visible to each other, right? So that must be. I don't know exactly what port.
Cluster mesh. Okay. Yeah.
Yeah, I think it's cluster mesh. I don't know exactly what port you need to open, but I guess it's the cluster API mesh port, cluster mesh API server port. So that port has to be open to each other, right? So you gotta be creative. Of course, like I think there is no opinion there. You have to.
I'm also. I mean, I might be guessing at this point, but that port maybe it's configurable as well at some point, right? As long as it's configured the same, right? As long as cluster A knows how to talk to cluster B on which port to access it, I think it shouldn't matter. But then also, as you said, with it's either node port or load balancer. I don't know what other ways you could expose it though, but yeah, Egbert, if you could clarify maybe, or if you just say if that answered your question, that's fine as well. All right. I mean, we can hang around for another minute or so, see if there are any more questions. I still see people in the stream, so thank you for sticking with us for an hour and a half. There's still quite a few around here, so yeah, keep the questions coming.
Yeah, a service needs to be deployed in both the clusters for cluster. Well, in order for doing things like service affinity and locality routing, then yes, you need to have services defined uniquely in each cluster. But you can also have a service defined in one cluster and then do cross-cluster communication if you want to, because you're not going to have mirrors all the time of your clusters.
But service in this case would be the Hello World service.
Yeah, like if you were
like a Kubernetes service, right?
Exactly. And if you were trying to make it load balanced in the sense of high available as well, so it would be available in both clusters.
Yeah, theoretically, yes. Yeah. And multiple. Yep. But if you would deploy it in just one, then you probably, why would you have in a second cluster, why would you have a deployment running there without a service? You wouldn't. I mean, theoretically you could, but it's not helpful because you won't be able to access it, right?
Yeah, that's true too. Yeah, exactly.
It's not like you're not defining I'm drawing on my Istio knowledge, right? You're not defining a service entry that's global, right? To use that one, it has to be the actual physical Kubernetes service in each cluster, I think. So,
yeah. It's my impression as well. So,
yeah. All right. Feel free. I mean, ask more questions. I still see a lot of people watching and listening in, but not asking questions, which is fine as well. We're not gonna make you ask a question, but
yeah, I think it was a really good 3 days of being able to cover an array of Cilium topics. Like there's just so much to cover in Cilium alone. And then you have the knowledge that goes beyond what Cilium can offer, right? In any case, I recommend everyone go back and review day 1 and day 2 so that they can set themselves up for the foundations for this day as well. We're also going to dig into creating a mock exam at some point in the new year. I don't know when we're going to live stream it, but it will be sometime in the early new year. So that we can effectively, give you all a sense of what the exam would be like. The exam isn't available, but we're just going to base it off of the knowledge that we put together.
Yeah.
It's only multiple question, right? So
Multiple choice, yeah.
no.
So question, does Cilium work together with Istio?
Yeah, of course. It's actually, there's a whole section on the Cilium docs. It accelerates Istio networking because of the BPF, and of course there's a as a CNI, it works very well. So
Yeah, I'll paste in Egbert. I'll paste in an article that Christian wrote that basically talks about how to run Istio with kube replacement, kube proxy replacement in Cilium. So that one goes into details and explains it, right? And some of the things that you have to make sure to set, specifically the host namespace only setting, right? And then the kube replacement set to strict, right? Or true, I guess. So. All right. Well, I think we'll see if any more questions come up, but I think we're not going to get more questions. In any case, thanks everyone. Feel free to reach out to any of us. Let us know if you like this or not, and if there's any specific topics that you would like us to cover in the future or in 2024. I'll say, because I don't think we're going to do anything substantial this year anymore. So yeah, let us know. And thanks, Marino. Thanks, Alessandro, for the demos and presentations. And happy holidays to everyone. And we'll see you, I guess, next week. We'll see you in another stream, but then in 2024 here. Cool. All right.
Take care, everyone. Thanks for coming by.
Bye.
Happy holidays.